Hello and welcome. My name is Shannon Kemp and I'm the Executive Editor for Dataversity. We would like to thank you for joining today's Dataversity webinar, Trends in Data Modeling, this year's latest edition in a monthly series called Data and Online with Dr. Peter Aiken, brought to you in partnership with Data Blueprint. We at Dataversity, so without further ado, let me give the floor to Megan Jacobs, the webinar organizer from Data Blueprint, to introduce our speakers in today's webinar. And fabulous. We can see the presentation again. Perfect. Megan, hello and welcome.
Thanks, Shannon. Hello, everyone, and welcome. My name is Megan Jacobs, and I'm the webinar coordinator here at Data Blueprint. We are pleased that you found the time to join us for today's webinar on trends in data modeling. As always, a big thank you goes out to Shannon and Dataversity for hosting us. We'll get started in just a few moments after I let you know about some housekeeping items and introduce your speakers for today. We have 1 hour presentation followed by 30 minutes of Q&A. We'll try to answer as many questions as time allows, but feel free to submit questions as they come up throughout the session. To answer the top 2 most commonly asked questions, yes, you will receive an email with links to download today's materials and any other information you request during the session within the next 2 business days. You can find us on Twitter, Facebook, and LinkedIn. We set up the hashtag DataEd on Twitter, so if you're logged on, feel free to use it in your tweets and submit your questions and comments that way. We'll keep an eye on the Twitter feed and we'll include answers to those questions in our post-session email. Now, let me introduce you to our presenter. Peter Aiken is an internationally recognized data management thought leader. Many of you already know him or have seen him at conferences worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions to the profession. Peter is also the founding director of Data Blueprint. He has written dozens of articles and 8 books. The most recent is Monetizing Data Management. Now, Peter, I'll let you introduce our guest speaker for today.
Thanks, Megan. So real pleased to have with me today Stephen MacLauchlan. Stephen has a very, very interesting career. He's been the head of marketing and PR for a game development firm. He spent a lot of time in application development, and then, like many of us, came to the realization that if we could get the data part of the application stuff right, things would be easier. Not easy, but easier. And that's, of course, all we're trying to do is to help people get to easy on this. Stephen, like all of the Data Blueprint associates, is a certified data management professional. He has a computer science degree from VCU, and he's done a number of different things, including some activities on the outside where he has his own podcast that he has. And we did forget to put the link in there. We'll put it in the follow-up on that. But tell people what that other podcast is.
So that podcast is about the broadly appealing topic of historical miniature wargaming. So I'm sure almost everyone out there knows what that is, right? Okay, so nobody knows?
Little toy soldiers.
That's right. They're basically little toy soldiers, and it's a very niche little industry, and it's a lot of fun. So yeah, I have a series of websites that deals with that, mostly historical games, but other things like board games and some of the newer stuff you guys might be familiar with as board gaming becomes kind of a newer trend. So pretty interesting.
Very cool stuff. So again, well-rounded individuals we have here.
That's one way to put it.
So Stephen, terrific to have you with us today. We're going to talk about trends in data modeling. And what we wanted to do was to bring all of you into sort of what we're seeing in the marketplace. So while there's a lot of talk at various events and things, Stephen is actually on the front lines of seeing how this stuff is implemented on this. Now, just to start out for everybody's background here, we collectively believe here at Data Blueprint, and I think Dataversity can be included in that group as well, that data is the most powerful yet underutilized and poorly managed organizational data asset. Assets are resources that need to be controlled by the organization because we're going to have some benefit in the future. Very, very simple proposition, but harder for a lot of people to actually put their finger on it. Data really is your sole non-depletable, non-degrading, durable strategic asset. And when you compare and contrast it with other types of assets that we have, some people will say it's the new oil. Some people I've seen write it down as the new soil because you can plant things in it and they will grow. Or we've even got one group that says it's the new bacon. Okay.
I would take that a step further and say it's the new bacon mayonnaise.
Bacon mayonnaise. There we go. All right. Like those bison burgers we were eating the other day. when you compare that to data assets, to financial assets, real estate assets, and inventory assets, we manage those assets in a very different manner in which most organizations manage their data. So our goal here is to help you all unlock specific business value in your organizations by strengthening your data management capabilities, by providing tailored solutions to your specific business problems that you're having, and building lasting partnerships with you overall. So let's dive into the presentation, Stephen. What we're going to talk about today.
So you'll notice there's a bit of a focus on NoSQL kind of towards the middle there. I think that's just some emerging trends that I think might be kind of interesting. A bit of a high-level approach to it today. I'm not going to get too far under the hood, but thought it'll be kind of interesting to sort of approach those from a broad spectrum. But starting from the beginning, we're going to go back over what really a data model is. We hope that most of you joining us are already familiar with those concepts, but just in case, we're going to walk through what a conceptual and a logical and a physical data model is. And specifically, we're going to tie that in by addressing what issues poor data modeling can introduce. And you all, hopefully, all are familiar that there are a myriad of issues that can introduce. Then we're going to go into different models, different uses, where the focus is really going to be the right tool for the right job as opposed to one model to rule them all. So we're going to talk about, again, like I said, some of the NoSQL architectures that are sort of coming to the forefront now. And then we're going to tie it off by talking about kind of how it's changing. We're going to discuss patterns and reuse, this growing abstraction for application, and data sharing. We call that data sharing the world, right? These APIs that are going to just make data available to everyone and anyone who wants it. And finally, we're going to end with scaling out, not up, and a few thoughts about things like sharding, and make sure not to shard yourself.
Right. We knew that was coming.
I warned you guys.
Great. All right, well, let's dive in and what is a data model as far as that goes?
Right. Okay, so a data model, as you all are familiar with, it basically organizes your data into elements and standardizes how the other data elements relate to one another. Pretty straightforward. You guys have seen them probably all throughout your daily life. In Data Modeling Made Simple by Steve Hoberman, he said, a data model is a wayfinding tool for both business and IT professionals, which uses a set of symbols and text to precisely explain a subset of real information to improve communication within the organization and thereby lead to a more flexible and stable application environment. That's a bit wordy, but I really think that's a pretty exhaustive explanation right there.
Another way to think of it, too, is, and Steve really concentrates on this on his definition, which, again, is what you do in the practice, which is the idea that we really all need to be on literally the same sheet of paper. Right. And one of the other things you don't know about Stephen is that he's also a musician and has had a band in the past and did well over 1,000 shows out of the back of a van and lived that way.
Which isn't as glamorous as it sounds.
but as a musician, you can appreciate the fact that we need to be on the same sheet of paper.
Absolutely. And it's a common language for you to speak, right?
Precisely. And that's exactly what we're trying to do with the models here, is to provide that same kind of commonality in there.
Right. Okay, so we're going to talk about how data models are expressed as architectures. Primarily, I think the main idea about them is that these attributes of these entities are organized into entities and objects, and that's graphically represented typically. Lost my screen for a second. It entitles. I'm sorry, that says entities, doesn't it? Entities, objects are things whose information is managed in support of strategy. And let's hit the next one so we can show a couple of examples. Yeah, and then, there are a bunch of examples of entities organized into objects here, but and attributes organized into entities. We'll get to architecture, though, which is a little bit harder to show the examples. That's the reason. I'm glad I read that typo. That was pretty pro level. Combinations of attributes and entities are structured to represent information requirements. That's pretty straightforward, right? You're thinking of a customer. You're thinking of an address, right? You're thinking of a shipment or a product. And poorly structured data constrains organizational information delivery capabilities, right? And that's just clear, I think. If you have poorly defined customers and you're trying to ask questions about your customers, that's going to add all kinds of complication on top of that, as I'm sure most of you have come to be familiar with.
And many of you have heard me make this analogy as well. One of the things we absolutely try to get the clients that we're working with to do is to not label things at the wrong level of abstraction. For example, customer is almost always the wrong level of abstraction. A very simple example is if you're talking about customers and you say mail a coupon to our customers, and some of your customers are current customers, and you're telling them the thing they bought yesterday is now cheaper as a result of this coupon, you end up with a very bad taste in their mouth. So we almost always need to take our customers and divide them up into different subtypes. Again, current customers versus potential customers is one way to think about it.
Right, and I think you'll see a common theme about what Peter's talking about here, and that a lot of thought needs to go in at the front end if you really want to get the most you can out of the back end, I think.
We'll look at that going from more granular to more abstract, and finally the last part of it.
That's right. So the models are organized into broader architectures, and so when building new systems, architectures are used to plan development. And more often, data managers do not know what existing architectures are, and therefore they can't make use of them in support of strategy implementation. And you see that all over the place. You see siloed systems coming up, not even realizing that the next building, the next office, maybe the next cubicle over is already doing something that you're trying to do as well.
The reason we don't have examples at this level is because architecture is a much broader topic, and it takes a lot longer to walk through these. So once again, you all in our audience have your own examples of architectures, and if you can practice that process of explaining to people how useful or not useful that particular architecture is. And this gets to another component of this, which is something that we also like to practice for everybody, which is to say that don't put a model together unless you have a purpose statement for that model. Right. We're doing this model in order to achieve X, Y, and Z, whatever X, Y, and Z are. And if you're not, it just becomes an exercise in nice practice, but probably not business value. And of course, that's where we really want to concentrate.
That's absolutely right. So going to review a little bit of some basic knowledge for some of you, but this may be new information for a couple of you listeners out there. The idea of the conceptual data model, and we've mentioned earlier, there's basically three levels. There's the conceptual, the logical, and the physical. The conceptual data model really represents entities and relationships, and it should identify the domain and scope of data. This is exactly what Peter was just talking about. At this level, it really should be easily understood by business users in order to communicate core data concepts and drive application requirements. Right, that's exactly what Peter's talking about with music, right? Everyone's looking at the same sheet without going too far into the theory behind what makes that music enjoyable. Right, this is a very high level. You're saying this is a customer and he lives at this address, just like in our example there. Right, so, and what isn't necessarily fleshed out at this level, although it can be, is, for example, a customer may have many addresses, or many customers may share one address, right? That's pretty straightforward. That will absolutely be represented at the logical level, and it's a bit optional to be represented at the conceptual level. I would argue that it should be, but.
So let's look at a specific example around this. Here's an example from the Veterans Hospital system that we were working on in the early 90s. Now, this is an example of how data modeling was done in the past. Again, one of the reasons we're doing this particular webinar is because we wanted to bring you guys sort of up to date with some more modern techniques, but this was a very good traditional use of the data model. And you'll notice that I've circled the relationship between admission and discharge. So we have a question that has occurred about that at one point in time. And we can look and see that the admission associated with one and only one discharge. We can also then look by the data model and see if we can see what the difference is between an admission, in this case, and an actual discharge. So when you look at these two here, and the circles are slightly off on your screen there, but we can look at the precise definition. Now, one of the things that this gives us is the understanding that every admission must have a discharge. So therefore, one of the things we brought to the attention of the group we were working with at the time was clearly one of the things in terms of being discharged for was being dead. Right. I know that's not a very happy subject to talk about, but if that's the type of thing we're doing, we're saying we have to be comprehensive about it, and clearly you leave the hospital, you're either alive or you're not.
That's right.
And so, again, the model here allowed us to circle in on that particular topic and allow people to see how that actually worked. We can take it a step further, diving deeper down into the process and look specifically around a particular entity. So you'll see this entity called bed had 4 attributes: bed.description, bed.status, bed.sex to be assigned, and bed reservation reason. Notice also below it, it has an association with a concept called a room. A room can have 0, 1, or more beds in the room. Now, this was another area where we discovered that there was a little problem with the way in which the system was being specified originally. One of the things that was going on in the early 90s was that people were discovering this new technology called RFID. And RFID, while it was really neat, they thought this would help avoid losing people in hospitals. I don't want to scare you guys, but it does happen occasionally where somebody will get lost in a hospital. And we pointed out to them that if a bed could contain a room could contain 0 or more beds, then, and we were going to use the RFID to track where the bed was in which room, then what else had to be a room? And it turns out, that meant a hallway had to be a room.
Or an elevator.
And an elevator, exactly right. And of course, that was what really blew their mind because they couldn't figure out every room had to be on a floor.
That's right.
Unless you're an elevator, in which case it didn't work. So not that this is bad or good, but it caused some questions to be asked. And it's great to ask the questions when you're at the conceptual stage as opposed to I've already built it, now I have to go back, undo what I did, and get back into it the other way. So that's conceptual modeling at a high level. Now we're going to move to logical modeling.
That's right, and so the logical model is really just sort of the next level down, right? We're now going to represent the conceptual data model, and it should be very close to the conceptual data model, but we're going to be a bit more thorough. In this case, we're going to include attributes, we're going to include names of entities more clearly, we're going to explicitly identify the relationships and any other metadata that we might want to put around this. This level right here, I think, is what most business users will still understand, and certainly all IT workers should understand. So this is really your common ground here, in my opinion. This will be developed using a data modeling notation. For example, UML is typically the go-to, although I've seen lots of other things from scrolling on napkins and so forth, which is not the best practice. So in this case, you now see that customer has an address. And not written there is the inverse relationship of that, is that address could have many customers. So this is a many-to-many relationship between the two. And you can certainly think of plenty of real-world examples for that. But we've now gone beyond what a customer is by explaining exactly what attributes make up a customer. Clearly this is not exhaustive, being just an example, but in this case, for this business purpose, we've identified a customer as having a customer number, it's probably their key, possibly a surrogate ID. They're going to have a social security number, their first name, their last name, their salutation, and a phone number. Right now, I would actually argue the phone number should possibly be pulled out of there, but that might be over-normalizing. And then your address is going to have a street, city, state, zip, country, pretty straightforward. But those are the things that identify that entity and how the two relate to each other.
And notice we don't have anything about the customer's dog in that particular place, which is an explicit business decision at this point to say that we're not going to talk about dogs. Not that we have anything against dogs, it's just not part of the business problem at this point. So it's what you include, and by definition then what you exclude also. At the conceptual level, we weren't looking at that specificity. Now we are.
Right. And without going too far down that rabbit hole, right, how much redundancy do we see out there? How much data should have been excluded in the first place? But we don't need to go down that right now.
Well, but it is interesting in the sense that Lewis and I argue about this all the time, and I think that about 80% of the corporate data out there falls into the category of redundant, obsolete, or trivial. He thinks it's closer to 95%.
Yeah.
So neither way, the two answers are not good.
Right.
So conceptual, logical, of course, everybody knows the next step is physical.
That's right. And in the physical data model, we're going to describe the specific database implementation of the data. I've seen physical data models really vary pretty wildly between organizations, and even a couple of different standards organizations, I think, have sort of different definitions. I'm going with the fairly middle-of-the-road idea that it really is describing within the specific technology you're using. So something like Oracle or SQL, you're going to be using that notation. Consequently, the attributes will now be named according to either your business or your technology naming conventions. You're going to see your data types. You're going to have accurate table names. You're going to have key information. Your relationships are going to be built out further into the structure they're actually going to be represented as physically. And so you can see the slight variations here between this and the logical. So we now see the naming conventions, and the keys, and so on and so forth.
Again, one is higher level, it communicates more to the businesses, whereas this is clearly more of a technical focused piece on here. And before we move on, let me bring everybody up to date with one piece that has happened here. Stephen mentioned in the last slide UML. In the data modeling community, there used to be a bit of tension around people that used UML because UML had some challenges originally where it was not really representing the full robustness of what we do in data modeling. And the people at OMG reached out to Dana and put together a group. David Hay was instrumental in working that particular piece, and we now do have an improvement in UML that allows us to do robust data modeling in there. So that's the first thing. It used to be 20 years ago, people would go, oh, I'm not going to go into UML because I've got to get really hairy with my normalization. And if I do that, I'm not going to be able to do it in UML. The answer is now we, in fact, can do this.
That's right. So now we mentioned earlier, we're going to just talk a bit about some of the consequences of poor data modeling, and they can be quite vast, actually. You're seeing plenty of issues around that. So right off the bat, poor data modeling up front can cause data quality issues downstream. We all probably realize that. If the model isn't a true representation of the business concepts, it's going to impact confidence in the data. And we see that quite a bit, right? If a worker says, I don't trust that data, well, then that data is as good as useless to them, right? There's a potential for poor database application performance for reads and writes. So, you can over-normalize, and we're going to talk a little bit more about that, but if it's taking ages for your beautiful data model to do what it needs to do, right? If you're trying to load an application and it takes you 5 minutes to bring up one customer, well, then you probably need to rethink your data model or your technology and your architecture for it. Typically, it's a good place to start with, looking at the data model.
Yeah, we get the question oftentimes, can you come help tune our Oracle system? And we'll pretty quickly figure out that it's not the Oracle system that's the problem, it's the stuff you're putting in the Oracle system.
That's right.
Yep. Just gave a good example of that.
Right, and I think this is a big one that we run into, is this lack of flexibility in your data model can cause difficulty aligning with evolving business requirements. And what that means is you constrain yourself within the data model. You didn't think about the future being flexible. And so what happens is you wind up overloading fields. I mean, how many times have we seen an email field in something like, I don't know, a date of birth field or just something where it really doesn't belong? And that causes problems for people who that hasn't been communicated to.
I can stuff that in that field without asking IT to fill me out a bunch of forms and triplicates and all the rest of the things. And, of course, that's where you end up with real big problems.
Okay, really quickly, just because it's fresh in our minds, I'm going to respond to one of the questions there, saying what's the consensus on reference tables? And I absolutely agree with that. Right, having state as a free type field without a reference table absolutely does not make sense. And I'm a big fan of those tables, and especially nowadays that there's so many data services out there, you can actually get USPS information for addresses and make sure they're validated. So just to answer that question quickly, yeah, I think that example certainly is something we could really scrutinize over and over, because again, I think that state should be separate. Really nowadays, I think address should be a validated field. So I'm sorry to answer that in the middle, but I thought that was pertinent right here.
Yeah, absolutely. And then again, what are we going to do when we add the 51st, 52nd, 53rd states
That's
to this?
Exactly right. Yep.
Everybody want to go back and reprogram that? I think not.
That was a good question. Difficulty integrating data in the future. I'm going to be honest with you, this is probably the biggest issue we face day in and day out, is integrating data. And I think it's a little bit of a recursive problem, right? What happens is someone doesn't trust the data. So then they build their own system that's separate, that meets their own needs. They don't trust the other data, and then that happens again in the next office building, or that happens again in the next line of business. And then some executive says, hey, I want to put these things together. And that's when someone says, ooh, you know what? Not real sure how to do that.
Who are you going to call?
That's right. so that's a big deal. And that's, especially nowadays as we're moving towards, obviously we very much believe that not having a grasp on your data is going to be a major impact in your future. So, it's a big one out there. And we've kind of talked about that already. It constrains your business agility. I guess I won't really revisit that. I think you guys understand that it's basically tying you to a model if you're not careful early on.
And again, if it's the model that wasn't really well thought out, then you're left with nothing but workarounds in the future.
That's right. That's exactly.
That's the real problem with most software packages, is that they tend to have their data models not as well thought out as a data modeler might do it.
That's right. And speaking as a developer, I've never, ever done a workaround, right? Scout's honor. Okay.
I think he's got his fingers crossed on that one, guy.
And again, it can create operational inefficiencies. I think that's more just feeding into what we've been saying. Now, this is an important one too, right? It does limit workflow transparency. It can be difficult to tie everything together when you're across multiple systems or multiple silos because you had to expand that way. So I think that's a pretty good one. Do you have any thoughts on that? Because I know that's something we've run into time and time again.
The real key there, and I heard silos described differently at a conference last week.
Right.
They're considered to be cylinders of excellence.
Ah, that's beautiful.
I love that. but you're right in the sense of tying them together. We've got a lot of different parts, and probably many of your organizations have the same situation, where you have data in separate places, and somebody sort of has chocolate and somebody else has peanut butter. Mm-hmm. Unless they happen to round the corner and bump into each other while they're both holding a pile of fudge and a pile of peanut butter,
right,
they never really know that was the case.
That's right.
So unless you, in gender situations, try to have regular meetings, this is a part of data governance, different webinar topic, we did that one actually last month, but unless you have a mechanism for saying, come to the table and share what data you have with other people, it becomes very, very difficult to understand these things, and people find out by happenstance, and we'd rather have them find that programmatically.
That's exactly right, yep. I think this kind of supports what we're saying, right? We just know that it's impacting actual business processes, it's impacting your insights, right? If you can't get a full view of your customers, that's a problem. Like, everyone now wants to jump to this new trend. They want to have big data. I want to have predictive analytics. Well, guess what? You can't get to that if you can't answer simple questions like, who are my customers? That sounds dead simple, doesn't it? To say, I'm an executive here, and I want to say, who are my customers? How many customers do we have? That is not an easy question to answer when customers are spread across 3 different silos, and they have different definitions and different systems, or, this person hasn't bought anything from me in 24 months, are they still a customer? We're getting a bit into business rules here, but I think it's very pertinent for the data model.
Let me give you an example of one of the things that happened on one of the projects that Lewis and I were on many, many moons ago.
Right.
We were implementing a data model that was going to go into production, and we discovered an error in the data model. And we told everybody, sorry, we just discovered this. It was a late addition, a late requirement. When we incorporated the requirement, we could tell that the data model that we're about to field is inadequate.
Right.
And management said that doesn't matter. It's going to go out Monday no matter what. Mm-hmm. And we were able to add up the amount of overtime that it took the staff of 300 programmers over the next 6 weeks to go back and do it. And management came back and said, well, we should have listened to you guys because clearly we know exactly how much overtime we just paid over the last 6 weeks, and it would have been a lot cheaper than delaying the project by a couple of days to get that particular piece of it right.
That's exactly right. Yeah.
So let's move on a little bit.
Okay.
We'll dive in a little bit now into normalization.
That's right. I'll let you take this one away.
Yeah, we're not going to repeat for all of the wonderful data models that are out there what the normalization process is. I will say, though, that as data modelers, it's not the conversation we want to have with executives per se, but it is important to be able to explain the business consequences of not normalizing.
That's right.
And because it's taught so haphazardly in most educational circumstances, even good, smart IT people didn't necessarily get a good education in that. And when that happens, it makes it harder for everybody to have this kind of an understanding here. So the basics are really what we're trying to do is set up the situation here where we would love to have the vast majority of data models analyzed at third normal form.
That's right.
And then this is the part most people don't get around to understanding, and denormalized, of course, for production constraints. And you alluded to that earlier, Stephen.
That's right.
So what we tend to teach in college and university here is a model that looks kind of like this. Now, I use CM2 because I use that abbreviation as Common Metadata Modeling on here, which is really what we're talking about in terms of everything. If we start at the lower left-hand corner, we have our physical as-is. We then are taught to move to the logical as-is. And if we're not going to change the requirements, we can then move to the logical 2B, that's quadrant 3 up here on there, and then finally the physical as-is model. Now, we know that as data modelers, most applications people do not understand the need for that, and they go strictly from technology-dependent physical to technology-dependent physical. Mm-hmm. That's a problem. And if we can't explain the reasons why that doesn't work in terms that mean things to executives, which means you're usually explaining it in terms of dollars or bodies one way or the other, it is going to be a problem for us. But it's gotten a little bit more interesting too. Even if we do understand this model, let me take you to that same model and do slightly differently with the whole thing. So again, we start out here, and this little green blob that you're seeing on your screen now goes from your physical as is to your logical as is, your logical as is to your logical to be, and your logical as a 2B, right, and then you go to your typical 2B. All right, well, you get that. That's the way we tend to teach it. But what really is happening here, we're not doing this unless there's a change. So somebody said, I need to have some sort of a change. So when you go up to this logical as-is situation, something else happens here. We have other logical as-is data architectural components, other models that are out there that need to be integrated. And you mentioned before, Stephen, how difficult it was to integrate things if you didn't have transparency into it. Profiling can help give you some insight into those ideas, so profiling is a tremendous adjunct for the models. But if you look here, I've got some green and some orange requirements. And what we really need to do is to take that logical as-is model and transform it to where it incorporates these new capabilities. So I've done something clever here with PowerPoint and just sort of made it look like it's green and orange in that, because then we take that new revised model, move it over to our logical to be, and then drop it into the implementation context. In fact, if we step away from this a little bit, we can actually look and see that anything we do in our model transformation is going to be constrained within this particular framework here. Again, as is and to be, and at the bottom, conceptual, logical, physical. I do one more thing in this as well, and that's that I validate the models as we're going through. And that's the process of asking the users to try to prove us wrong. Remember, of course, if you ask them, how is it, and they say, fine, no information is transferring under those circumstances. But if I say, what's wrong with this model, everybody loves to be a critic, and they can dive into this. So this space here that I'm showing on the screen really conceptually represents the world in which we operate in there. So let's go back in and look at third normal form and specifically talk about where things are within that context.
That's right. So we'll start off with, I think, what Peter touched on is kind of what you all are probably familiar with seeing in the wild. It's certainly probably 90% of what we deal with is your standard third normal form or relational system, where each attribute in the relationship is a fact about a key, and this is just like the examples we were showing earlier. This is a highly normalized structure. This is the structure that for many people out there, just because it's been around for ages, makes the most sense. It meshes in your head, right? Sometimes I find after I've done some intense data modeling, I start to see everything in my life in third normal form, you know? I'm sure you guys have done that before, right? No? Okay. Nobody else?
Megan's shaking her hand.
I'll
get you there, Megan, don't worry.
So some typical use cases, right? Transactional systems, operational data stores, lots and lots of applications out there in third normal form. Just giving a quick example here of a record label, and again, I think you'll even see some of the questions in the Q&A. This is certainly not even fully normalized. Again, we're seeing address information, right, in the same record as or in the same table as the record label, and in fact, what if a record label has multiple addresses? So it's not a perfect model, but I think you guys get the idea as an example.
And when we talk about third normal form here, Steve, what you're really talking about is a class of modeling to do problem solving.
That's
so
right.
Third normal form is a way of fully understanding the model at its most flexible, most adaptable situation. If we go back to the slide a couple previous to this, you saw I had fourth and fifth normal forms up there. Those have some additional capabilities that will allow us to draw out specific business rules. But if you get to third normal form, that's generally a good place to look, to stop, take a pause, and see if there are portions of the model we need to go further with it or not. So from a traditional perspective, this is where most people are taught, the tool set that they know how to use, and it's a good solution for many types of problems.
That's right. And I think if you'll hit the next slide there, we do have some pros and cons. So as a pro, it's easily understood by business and end users. Again, this is where you're going to find most of the expertise out there today around. There's reduced data redundancy. That's handy, particularly it takes up, theoretically, it takes up less space on disk. You've got nice and forced referential integrity, so if you're doing things like someone mentioned in the Q&A, you have your lookup tables, your reference tables, and the indexed attributes and flexible querying, and really that should be at the top in my opinion. I think the biggest strength of this is the technologies that support this really provide for some very rich querying. I mean, you can take a relational system and ask a lot of questions about your data and get a lot of ad hoc answers. Moving on to some of the cons, Joins can get quite expensive. We mentioned that earlier. We have this example here. Neo4j have that as an example on their website. They call it the join bomb, and you can just see how ugly that is. And consequently, it doesn't scale well. So if it's a single user, single tenant application, it's probably going to be fine. But if you're talking something like Facebook, like something huge, then it's probably not going to do the job. It's going to choke.
So when we talk about the modeling at the third normal form, one of the things, again, that's important to do is to make people understand you have to have some time in order to do this. You can't just put the model out there going from your logical model to this, but you really do need to analyze it. And again, if you've got a business example, at least in this company that Lewis and I worked for, that I gave you the example a few minutes ago of having the raw model, they got it. They understood that 6 weeks of overtime and everybody working on the weekends was really a bad outcome for the organization to correct a problem that was easily definable. In fact, we had defined it up front in order to do this. On the other hand, it's a little hard because when you start talking about third normal form, you actually end up with more boxes on your chart. And it looks like more data. And you've got to be really, really clear to make sure that people understand just because you have more boxes doesn't mean you have more data. The boxes represent a class of items, and we're breaking it down to a different level of granularity. That gives us the ability to end up with overall less data. Again, each table that we have out there in the system should represent one fact and one fact only.
That's right.
In there.
Consequently, there's not a lot of redundancy, which there's plenty of pros for this, absolutely. However, we're seeing, as businesses evolve and as the web continues to grow, we are seeing that it's not necessarily meeting every business need like maybe it used to be able to do, come close anyways.
And therefore?
That's right. So we'll go ahead and move on to the next one that is probably something else you guys are familiar with, maybe not everybody, but certainly most anyone working in BI or doing any kind of analytics, is the concept of a star schema. Right? This is comprised of fact tables, they're centralized fact tables, and they're typically quantitative data, and then any number of adjoining dimension tables. So those dimensions are rapidly changing, or they can be sliced and diced on when you're doing analytics. And again, as I mentioned, star schema is absolutely optimized for business reporting. So a couple of use cases, right? Online analytic processing, business intelligence. Peter, you have anything you want to add to this one?
It's really just people, when they look at star schemas, we try to speak to them about n-dimensional problems. You're showing a 3-dimensional problem here. In many instances, it's 12 dimensions that are required. But then you also, as you start to add that complexity onto this, now you get back into your join bomb. Again, I like that particular.
Yeah, that's good.
We'll have to write a song about that
that's
one.
Right.
We have something in it. But this gets to the important part of it. If you let the user specify what they want, they'll give you, wow, I'd like to have one of these and one of these and one of these and one of these. Mm-hmm. You've had to deal with these requests before. The answer is yes, we can build it.
Right.
But it will cost you something. And so, again, if you're going to have 1 billion joins that are going out there, and by the way, star schemas tend to avoid a lot of these things.
Right.
So what you're trying to do is pre-structure and anticipate what the queries are going to be. But you can also prioritize them so that while everybody may say, oh, I've got to have all these dimensions, if you actually build the model, watch it for 12 weeks and discover that they're only using a little bit of the functionality,
that's right.
Then you can relax some of those constraints in your prototyping
that's right.
mode.
And that's exactly why you're seeing data marts kind of come around, right? These are marts that are specifically built to answer specific questions. So if we go to the next page, we'll talk about some of the pros and cons there. The pro is it's a fairly simple design. Now, I should have put an asterisk on that. I do find that sometimes people have a little trouble wrapping their head around a star schema, but typically it's fairly understood. Very fast queries, and most major database management systems are optimized for star schema design. So you are seeing a lot of support out of the box for a lot of DBMSs that people already have in place. So
again, a well-established pattern that people are familiar with, which also is very helpful. You throw something new at somebody, and it's going to take them a little bit of time to become comfortable with it.
That's absolutely right. Some of the cons is the questions must be built into the design, and again, I wanted to put a star on this. You could also see that as a pro if you really want to kind of maintain and know exactly what your data is being used for. But it's a little bit of a lack of flexibility, just that the questions are by design built in. And then data marts are often centralized on one fact table. And again, that's kind of a weak con, but
it fails, right? So that's it. If you want units, that's a very different set of structures.
That's exactly right. And so it can cause some integration issues, although you could just build another star schema for that. But again, we're seeing a little bit of a lack of flexibility, very specific problems that these are solving.
So those are the first two. What is the need for this third method coming
That's right. So this is one, we're actually pretty fond of this here at Data Blueprint.
Again, the entire team is certified in Data Vault methodology. So.
That's right. And so the Data Vault is really designed to facilitate long-term historical storage, focusing on ease of implementation. And we'll talk a little more about that, but the idea is these can basically be rapidly stood up because they don't really care if the data structure changes much, and I'll explain that in a second. They retain data lineage information.
That sounds like nirvana right there.
Yeah, I know. It's not all bread or milk and honey, but it's pretty good. The core concept behind it is this: all the data, all the time. And it's a bit of a hybrid approach of Inman and Kimball. I believe Dan Lindstedt sometimes, maybe jokingly or not so jokingly, refers to it as third and a half normal form. So it's a little bit differently normalized. And here's kind of the basics of it. And again, we're only kind of touching on the surface of this, so if this is something new for you guys, please don't hesitate to reach out to me or Google or whatever.
We can put another webinar together on this topic.
Because Data Vault's pretty interesting. But the main concept is it's comprised of these hubs. These hubs contain a list of business keys that do not change very often. So you'll see in this example a customer, right, an order. So these are your hubs. Then you have your links, which are associations between the hubs. So you're seeing right there the customer, and the customer has an order, so that's what's relating them. And then you're seeing satellites, and those satellites are descriptive attributes associated with hubs and links. And those satellites are interesting because they can basically change as much as you want because they're always relating back to a hub. They can add new fields, they can add new, they can remove fields and add new ones, and you're always going to have them. And I'm going to answer this question really quickly because I did say it. As to how you can reach out to us. You can reach me on Twitter at SJMacLauchlan. My name's hard to spell, but you can find it at the beginning of the presentation. You can reach me by email at smaclaughlin, no J in that one, at datablueprint.com. Sorry for derailing that a bit there, but
we should make an alias for that. We can fix that.
Yeah, no, I'm not going to make an alias for my beautiful last name. It's wonderfully long. So there are some pros and cons to the Data Vault. I got to be honest, it was a little hard for me to find the cons just because I'm really smitten by Data Vault, but in fairness here, it's got simple integration. Because of this all the data, all the time approach, it's really quite simple to integrate. It can house an immense amount of data with excellent performance. That's a little bit under the hood, right, a little bit inside baseball. And it's got your full data lineage, which can be really important for auditability, things like that. The con is, because it's so simple to integrate, the complication is really pushed to the back end. So it is going to require some ETL work to really get what you want back out of it, I think. It can be difficult to set up for many data workers, right? There's just not a lot of expertise around there. And I think that's going to be a con that holds true through the rest of these examples because we're going to talk very high level about some NoSQL solutions. And there's not a lot of widespread support for ETL tools. That's really kind of changing now. I think we're seeing newer and newer ETL tools are supporting this out of the box. But I think that was worth mentioning at least.
One of the things I like to think about as a use case for data vaults is an organization where they're set with a series of regulatory requirements. And when the regulations change, you don't want to go back and normalize the data warehouse to come up to speed with all the regulations. So what you can essentially do is freeze time at certain places.
That's right.
And you don't have to go back, but you can still compare apples to apples.
That's right.
Within the modeling method along those lines. So let's, as we're moving into NoSQL, talk a little bit about some of the things that are hypeful around it. And again, one of the things I like to introduce to groups is if they've not seen it, Gartner's 5-phase hype cycle methodology starts off in the lower left-hand corner there with a little green ball. It's a technology trigger. Cool! Somebody says, some of the data is more important than other data, right? So we get this great idea, and of course that gets us up to the peak of inflated expectations, where the hype outrises the actual business value, which means the next thing that's going to happen after lunch is that you drop into the trial of disillusionment. Oh, it sucks, right? Well, it's neither really good and it also doesn't suck, because we really need to find out where it is. We do that by climbing the slope of enlightenment and eventually landing ourselves on the plateau of productivity.
Right.
So again, a nice little description, and I just wanted to show you that because you have to see where big data falls into that category. Now, this is as of a couple of years back, but it's still fairly relevant. Text analytics, for example, has nowhere to go but up. If you're doing text analytics, that's a great place to be in, because the future, it's already been through that, wow, it's going to solve everything, or it really sucks. Now we're getting back to what it really can do. Similarly, if you're in social network analysis, the implication here is you're about to go through a rough ride. On the other hand, predictive analytics and web analytics have been well done, so those pieces are relatively mature in terms of it. Now that you've watched that, one of the things also to keep in mind here is that Gartner reminds everybody that the focus in on these big data techniques is not a substitute for the fundamentals of information management. I love that they included that.
Yeah, that was in there.
Similarly, then, if we look at July of 2012 and what's going on in here, we can see that big data was 2 to 5 years away from peak hype as of July 2012. Interestingly, just 12 months later, July of 2013, big data is now 5 to 10 years away from peak hype. Now, this is not to say that this stuff doesn't work. There are plenty of companies that are achieving very good business value by incorporating big data technologies into their architectural platforms. But how you're going to do that and how you're going to cut through the hype cycle that is there is something that you all are the best people who are able to come up with that. You know your business, you know these techniques. You can look at this and say, that tool will solve this problem and this tool will solve that particular problem. So let's get into a specific example on this.
That's right, and I just quickly want to introduce NoSQL. If any of you out there are unfamiliar with it, I do encourage you to take away from this a desire to read more about it. And there's a great opportunity that actually DataEd does. There was the NoSQL Now conference out in San Jose, which I got the opportunity to attend, and it was really quite interesting to see how this technology is maturing. Now, if some of you have heard the name NoSQL and thought, what does that really mean? It's a bit of a misnomer. It's kind of been backwards changed to say not only SQL, but honestly a lot of these do now support the SQL query language. And in fact, it's kind of a catch-all term for a lot of fairly different yet similar technologies that all kind of share something different. They're almost non-relational, although that's even a bit of a misnomer. So it's a bit of a muddy water to navigate. And again, feel free to reach out to me if you're interested, or Google is certainly your friend on this. But
so we can say a very technical definition, they're kind of blobbish, right?
In most cases, I would say so, yeah.
Great definition there.
Okay, so we're going to talk about document and key value here, and while they are different, they're similar enough to where I thought it was worth explaining. So these, kind of the key concept between both of these are that they're scalable thanks to a distributed hash table. And what that really means is, whereas a NoSQL system, right, because you've got your data stored in all these different tables, it's very difficult to get clustering. Now, I should add a quick caveat here. Almost every single technology vendor is working to address these cons. So I say this, and I'm saying it very much in theory.
And it's probably changed by the end of the webinar.
That's exactly right. So many SQL providers are attempting to account for these cons. And some of the cons you'll see me mention here, there are specific technologies that work to address those. So I'm talking very conceptually here. But the idea is that it can be distributed nicely, right, especially for something like web scale, some massive, multi-user, multi-thousands of users application, something like Facebook. You can have your data housed all across different servers, different geographical locations, whatever you may need. Now, this is the other kind of key feature, is it's a flexible, largely schema-less design. Schema-less, again, a bit of a misnomer, but we're really meaning that the schema is really handled by your application logic. They don't necessarily have to rigidly adhere to something you've defined. And so you'll see this example on the left there. That's really what a document might look like. That's a JSON. I've also heard it pronounced JSON. I'm not sure what's correct. That's a JSON document that basically will have a key and then this blob of document information. And it looks a lot like something like XML if you're unfamiliar with seeing JSON. And you basically have all of these attributes are actually grouped together now. So you might see Peter, right? He might have his address as a part of his own document, and so it's a very denormalized structure. And what that means is very rapid access, and it allows us to store them in different locations because of that distributed hash table. And so you're seeing the document concept on the left, and on the right we have a key value where it might be something much smaller than a document. I really think they're very similar in concept, but typically a key value pair might have something much smaller as the value. It's basically just a two-column table, right? Now your key could have something like username underscore first name, username underscore last name. So that could create a key for us. We might have Peter Aiken first name, and that'll bring up Peter, and then Peter Aiken last name Peter, right? So Aiken. So I hope that makes sense. I realize that for some of you this may be very new information, and there's a lot out there, and we have a bit to cover, so I'm going to move on from this. But quickly, the use cases, which we did talk about, applications with many users, many rights, very good for agile development, things like games, apps, right, mobile apps, because they are very empowering to the developer because these are schema-less designed. The schema can basically come up as needed. Okay. So document key value pros and cons, again, empowering the developer, and I put an asterisk on that one because, that's not always a good thing. No offense to developers out there. Very scalable.
Well-governed developers can achieve miracles.
That's right. Yeah, exactly. It's got high availability, and it's economically viable because you're scaling out. You can use a lot of economy processors as opposed to scaling up to buying the bigger and the better.
And let's be explicit there, you're talking specifically about parallelism.
Absolutely, yep. And sharding and auto sharding and all those fun things. And as an example, we have a Hadoop cluster here in the office that's running a bunch of old laptops that we just scrounged from around. So pretty interesting, really, and it's got quite good performance as well. Some of the cons, it's really got some poor ad hoc query and analysis capabilities, right? It's very difficult when you look at that document structure to say, find me all people who live in California. It is doable. You can index particular segments of the documents, but it can really be very, very complicated. There's a bit of a lack of maturity, and we're seeing that change. I think every day that goes by, more and more people are gaining expertise. Businesses are trying it out. People are gaining confidence in it. And in many cases, it's eventually consistent. And without going too far into the concept of that, it's basically if I write something and Peter immediately loads what I just wrote to, he may not see my change. And a great example of that might be like a Facebook comment, right, where it doesn't need to be immediate. I might post on Megan's Facebook wall and she won't see it for 5-6 seconds. And that's okay. It's not mission critical.
The eventual consistent gets into the difference between acid versus base.
That's exactly
and
right. Yep.
That's beyond what we're going to do here, but if you need some keywords to look it up.
I started to go over that in this presentation, but I took it out just for time. So here's a couple other NoSQL solutions, and again, I'm just trying to be high level here. We have an RDS triple store. These are purpose-built to store triples, and I put as an example something like Bob likes football. They have a query language specifically built for this called Sparkle, which is really fantastic. It's just got some amazing capabilities. And it's one of the pillars of the semantic web, right? The idea that the web is this, with the truth that it's this massive, unstructured data that if we could just harness and be able to query it really intelligently, right, it is unlimited power at our fingertips.
Read the right books and they think it's there already. And that's the key is to apply some of these techniques to it.
That's right. So then we have a graph. It's a structure comprised of nodes, edges, and properties. And you'll see it's actually pretty similar to a triple store. And it's focused on the interconnection between entities. Fast queries to find associative data. This is something like you might see in a social network, right? Relationships between people and how you can traverse those relationships. So you might see, Stephen is a friend of Peter, who's a friend of Meg, find all the friends of Meg, and find their friends of friends, right? It's easy to traverse that with this data structure, whereas with something like a relational system, that might be really quite complicated.
In terms of pulling all the joins together.
Right, especially if you have millions of records.
Whoops. Yep. Sorry, I made an error there.
So next up, we are going to talk about column family, and for those of you who are most familiar with relational third normal form, the best way I had column family described to me when I was having a lot of trouble kind of wrapping my head around it is think of it like a view, right? It's where your actual data is a view, where you've taken multiple tables together and combined them into a view. basically you can have unlimited columns on a row. And so columns are stored individually, but they're clustered by family. So as an example of that, you might see Peter, again, I like to use it as an example, and then you might see a column family of address, which features the columns city, state, zip, and then you might have a column family of car, and we'll see the attributes for your car under that. And what that allows us to do is have unlimited columns for any one record, but you can query only specific column families and still get pretty rich queries while excluding the other data. So we can basically have nearly unlimited numbers of columns without causing these expensive queries. Pretty interesting stuff. And so I just wanted to show you some examples here. There's an RDF triple store up there, right? Subject, predicate, object, Bob likes hamburgers. You've got a graph, kind of like what I was talking about, right? That dude is friends with that other dude, and that dude likes sushi, and that place serves sushi. So you've got all these relationships and how they relate to each other. So you can see how you can traverse these questions, which is really interesting. You can find, what friends of that dude with the beard like eating sushi, and you can traverse the graph and find that out. And then down on the bottom left there, you'll see an example of the person table in a column family. I think I pretty much went over that with Peter. So pretty interesting stuff. Not going to go over all these, but wanted to give you this in the slide deck. If you're interested in those, there are a lot of technologies to check up there. And there's a whole lot of variability, really.
Just about 5 minutes left. Let's talk about how all this is changing.
Absolutely.
The first key of this is that we want you guys to understand there's lots and lots of starting points to come from. We use these design patterns as ways of allowing people to understand this. And when people say, why should I investigate patterns, you can ask the question, have you ever noticed in large office buildings the restrooms generally are in the same place in every building? It's a visual clue and people know where to go. But in addition to that, it's also cheaper because if we put the infrastructure in one corner of the building, we don't need to run it out. Certainly it would be cheaper to have a loo in everybody's office, but probably a little bit impractical. And of course, we don't just stop with the loo. We repeat that for electrical wiring, floor plans, et cetera, et cetera. Well, all of these architectural patterns have different types of models and things. And I just wanted to point out here that David Marco, myself, David Hay, a lot of other people have written on these patterns in here. Some of them going as far in David Marco's book of including a disk with these patterns on them that you can get to directly into Irwin on this. So, Stephen, you had come up with some rules of thumb here that I found very, very useful.
Yeah, that's right. I found these somewhere. I'm sorry, I can't remember where. I found it on some blog ages ago, and it really stuck with me.
But they also come out true in what you see, though.
That's right, absolutely. So we're finding that roughly a third of a data model contains fields common to all businesses. Or 1/3 contains fields common to that industry, and the other third is really specific to the organization. So I think that's pretty interesting, really, to kind of absorb.
We'd love to get some empirical data on that. That'll require a different webinar to go there.
That's right. So patterns should theoretically provide an organization with a baseline to quickly develop data infrastructure. Are we seeing that in practice? Sometimes there's a lot of ERP off-the-shelf solutions that certainly do meet that. But theoretically, right, it should be easy now. There's so many people who've done so many solutions out there. If only we could just harness that. All right, so off-the-shelf solutions may require in-depth customization, and in many cases we see that off-the-shelf winds up being just as costly in time or money as just building something from the ground up, and that's really a bit of a shame. But
it's kind of like the outsourcing thing. Everybody went and outsourcing was going to solve all of our problems, and we discovered it didn't really solve all of them, so now we're back to where we started from. What's the right balance? And that's what we want you to take away from this.
Yep. So now we'll talk about data as a service. This is based on the concept that data can be provided on demand to any user regardless of geographical or organizational separation. And I think a good example is what I was talking about earlier with the USPS data, right? Theoretically, you could get by without really having address tables defined. I mean, well, that's not entirely accurate, but basically you have something at your service or at your fingertips, a service that provides that exact data you're looking for. And so consequently, especially in schema list data, you can enforce what I've been calling a post schema on your data. But you can shape the API. You can shape the way the data is fed or the way that it's subscribed to in a particular way to make it fit the molds that you need it to fit. And that can be as flexible or inflexible as necessary.
When you combine that with a data logistics network, that actually gives us a topic. We could do another entire webinar on just that one topic about being able to add schemas to things after piles of data have already been created.
That's right. So adding structured information allows us to obtain exactly what we want when we want it, and APIs allow applications to serve up data to external sources in a structured way. Again, this term post-schema. We did talk quickly about scaling out, not up. I'm not going to cover this too quickly, but the idea, right, is that by having this distributed hash table, we can have our data housed in multiple locations, multiple disparate locations, which means that you can scale out, not up. Again, I encourage you to Google that if you want to read more about it, since we are just about out of time here. And again, we've got that term auto-sharding, which I'm going to be honest, I'm a grown man, but I always snicker when I hear that. That's okay, right?
So we're right around back at the top of the hour here. Again, what we've looked at is really the relationship between these things, the different models, the different uses, and the fact that these things are changing. We've got a couple conclusions we want to finish with before we get to the Q&A section.
That's right. And that one, which I know you've heard us hammer home, it's very important to get data modeling right.
But you can't leave the explanation there. You've got to tell what the impact on the business is so that people understand. Again, in the example that we went into a little in depth, they understood how much overtime they paid to staff that was working very, very hard. That was fine. We never actually got to what the impact on the business was on that. We were able to make it very clearly a local case. But for you all, you've got to be able to say to somebody, think of it like an elevator speech. We couldn't sell chocolate last year. The reason was because the data model was wrong, right, or whatever it is.
Right, and go on to say getting it right is hugely dependent on the business case, the maturity of the organization, the flexibility for future growth, and so much more. And one thing that I really wanted to touch on but we didn't get an opportunity to is really this NoSQL stuff to drive it home. A lot of that is very application-centric. It's really letting the application drive the data model, right, for better or for worse. And clearly there's so many technologies and ideas out there now to solve a number of problems, and they're really solving very specific problems, and combining them all in very clever ways can really solve a huge variety of business problems.
And your organizations are dependent on your expertise in order to help them solve those specific problems. Probably the last thing, of course, we don't want you to model without understanding what the architecture is conceptually. If you don't have that conceptual framework, the modeling can become an academic exercise, or you can achieve a correct solution to an incorrect problem definition.
That's right.
So with that, we're at the top of the hour here. Megan, we'll turn it back over to you, and let's see what sort of questions we have. I know we've got a bunch of them out there.
Thanks, Peter. Thanks, guys. That was an awesome presentation. Now it's time for Q&A. Time for you all to ask your questions. So just click on the Q&A window feature at the top of your screen, and you should be able to submit your questions through that Q&A window. And I've had some roll in, but I'll just give it a few seconds for a few more to come on in. So just give it a little bit of time. All right, we'll go ahead and get started. And the first question is, how do you respond to developers who do not want to reuse corporate reference data code and say it's easy to create an XML mapping file?
That's a good question. I guess you can't whip them, right? No, I'm just kidding. That's a tough one, and I'm going to cop out a bit and say it really depends on the individual application. But if you're really holding your organization to informational excellence, I see no reason why they should not conform to what the rest of the organization is doing. If there's a compelling business reason why they could use XML mappings and kind of manage that themselves, then great. But if you've got great DBAs and data stewards and people, it could cause complication. And I realize that's a very generic response, but
I'm willing to bet, though, that most organizations, particularly as they get to be larger organizations, are going to discover that economies of scale are going to be more and more important. And that while you might be able to make a case for a local work group having a specific set of things on there, that when you look globally across the enterprise, and even if you don't currently have a need for it, it's probably pretty easy to forecast that there will eventually be one of those needs.
That's right.
That's one of the things that when Steve and I go into organizations, they'll be thinking, look, here's our 3-year plan, this is where we're going, and we'll be able to look 10 years out and say, yep, and after your 3-year plan is done, you need another 3-year plan, and by that point, you're actually starting to approach some of these enterprise applications. Now, the most important thing, though, is let's not devolve this question into a war about which side is right. Let's get the facts on the table so that we can, in fact, look, how many XML transformations are we talking about? How often is this going to run? When you start to put those numbers on it, and you realize that this query is going to run 8 billion times a day,
right?
Okay, that's something we probably don't want to have running that often if we don't need it to run that often.
Exactly right. Yeah, so again, I think the easy response to that is it really kind of depends.
But again, you all are the people who are closest to the ground, who have access to the facts and figures on this. One of the more enjoyable parts about what we do with all this is that sometimes you guys will follow up with us with specific questions, and we'll actually poke and prod and find out and come up with an answer to that might actually be not the intuitive one, that it's only going to happen 4 or 5 times, and the rest of it's all packages, and we don't have access to a lot of the internals. So yeah, let's make it a high-level XML transformation. Under those circumstances, it seems to be the best answer for your group.
That's right. Absolutely.
But again, let's do it based on facts, not just based on a quasi let's say religious war, but that's not the right analogy for it.
I mean, coming from a development background, I'm, no offense to developers out there, I'm loath to let them make business decisions. That no one should have let me make any decisions when I was a developer, that's for sure.
All right, great. The next question is, difficulty in integrating data is the big challenge now in the biomedical field. How can we address this problem at the stage of data modeling when designing a database with the owner of the data, when the owner of the database doesn't realize the future integration problem?
Well, that's a good question, and it's actually something that we see quite a bit. And just last week, I was at a biomedical luncheon, and I talked to someone extensively about how he's having these exact kinds of issues.
So maybe you have a fan who's stalking you.
Yeah, maybe so. If that's you, great. That was fantastic. Yeah, that's a great question and a very difficult one to answer. I mean, what you're basically saying is you're not getting buy-in on getting the model designed correctly up front. Is that right? Is that he's saying that the? Can you reread the last half of the question there? Just to make sure.
Sure. Let me get it.
Sorry about that.
No worries. Let me get it back up. How can we address this problem at the stage of data modeling when designing a database with the owner of the data, when the owner of the database doesn't realize the future integration problem?
Yeah, okay. I thought I heard it right. Unfortunately, that sounds like it's going to require some deft, maybe political maneuvering. I mean, that's really a business issue before it's even a data issue, I think, or at least it needs to be made a business issue. So maybe the powers that be need to understand why this is important.
But the key is to make sure that you present it to them in meaningful ways.
That's right.
So when I say meaningful, it's something that means something to the people in the corner office. So if the corner office is concerned with sales, then show them that the integration of this stuff will result in more sales, and the lack of integration will be a barrier to improving your sales numbers. And I don't think you're going to get sales out of biomedical, although, there's certainly some parts of it. Maybe what it is matches in disease or matches in genomic sequences. Lots of different things that happen there, but it's just incumbent on all of you all to say, this is important, and here's the business reason that it's important.
All right, great. The next question is, given new platforms, what are the skill sets that a data modeler really needs today?
And hey, Audrey, haven't seen you out there for a while.
That's a great question, too. And I think at this point, right, we know the old standbys. I think fully understanding your standard relational systems is always going to do you right. And I think on into the future, I think there's plenty of systems that are just never going to be replaced and never not going to be relational. I think at this point we're seeing these NoSQL technologies and these kind of, emerging trends in data modeling, but they're so new. I feel like at this point I've kind of made the decision for myself. I'm really taking a breadth-first approach. I'm really trying to just keep informed about all the different ones without really going down the rabbit hole of anything too far and seeing where that lands. I mean, I'm thinking in 5-6 years we'll maybe see 3 or 4 major ones really coming to the front, and that's maybe when it's time to attack it with more purpose.
So one of the things I do when I'm looking at technology forecasting, which is part of what Audrey's question is relating to in here, is that if you look back over the past 5 years in data modeling, we've probably seen more changes in the past 5 years than we saw for the 20 years before that.
That's exactly right.
So we are increasing the options, we're increasing the techniques, we're increasing the types of problems that we're adapting to. And that says we need to have people that can scale into these things, because the college and university system is not putting out well-qualified data modelers that are immediately useful to the business. I'm not saying anything bad about what's going on in colleges and universities, but when you're dealing with toy problems as we deal with in the university, it's very different from walking in and you were working with something that had to do with bone marrow sequencing.
That's right.
Out there. There's just no experience that you're going to get in college and university that's going to prepare you for that, or, for example, for an organization that has the kind of volume that some of these organizations are dealing with. When you do a query literally billions of times, that's enough to make even a fraction of a second a lot of difference in the organization adding up.
Especially for the business case, right? And I think part of what I'm saying is I think it's important to know about all the different tools out there so that you can know that you're using the right tool for the right job rather than going to one of your old standbys. And I've really been relating this to sort of the code revolution, right? I mean, 20 years ago, there weren't that many programming languages. There's certainly not that many major paradigm shifts. I mean, barring, of course, a couple of examples. But now there's so many different languages and programming paradigms out there that it has led to increased specialization and a little bit of fragmentation. I think we're going to see a little bit of the same thing with data modeling.
Fair enough. Got another question.
All right, the next one is, could you go over the difference between a data warehouse and a data vault?
Yeah, so briefly, right, a data warehouse is sort of purpose-built to have a single version of the truth, I think, whereas I would say a data vault is more about capturing all the data all the time and being able to get to the truth. That's kind of a high-level look. I'm not sure if you're looking for something more technical than that, but that's kind of the way I always go into it, right, because your data warehouse is going to be feeding your individual data marts, and those are going to be asking very specific questions, so your data warehouse is going to be gathering very specific data. Your data vault is more about just give it all to me, and we'll sort it out later. Like, give me all the data now, we'll let God sort it out later.
So again, nice high-level description of those too. Good question. Thank you for that.
Okay, the next one is, how do you address the performance issue where there is many-to-many relationship between entities?
Well, that's kind of exactly what NoSQL is all about, I think, in many cases. We can
go to two approaches.
Yeah, sure.
The first approach is a structured approach where you model it, come up with the intersecting entities, build in a set of structures, and everything stays right there. But the second approach, and that presumes that you know most about what your data is. So if you know what the answer is, you know exactly what your data looks like, you can build a solution relatively easy there.
That's right.
More often today, though, the data is not as well known,
right,
and the need for speed is pushing us into these other techniques, which is...
That's right. And as I mentioned earlier, plenty of technologies are springing forth to try to address these needs. I mean, even things like materialized views and ideas like that can help with this. But certainly that's a problem that people deal with every single day, every day. So you can denormalize in some cases where it makes sense to denormalize. You can beef up your infrastructure, which is a tough, bitter pill to swallow.
The hardware vendors like it.
Yeah, that's true.
All right.
Next question is, it says schema in a document or key value data store is handled in the application. Where does the logical modeling happen?
That's a fantastic question. I'm not sure I have a great answer for that.
It's most likely in the application package,
it
though.
It will be probably at the application point. It should be handled in some metadata surrounding the application, right? I mean, if you're doing it right, you should have metadata surrounding that so that there's some transparency, some buy-in. Realistically, though, it really is happening at the application level.
And the problem with that is that when you're in a largely packages environment, your data model is the one thing that ties together all the application packages. So I'm switching to a different presentation right now just to show you all a slide that I had developed that addresses some of this. And the key here is that what you see happen is that the reason they can get these software packages to work on a variety of databases is because they're using the database for just table handling, which means important functions like referential integrity are implemented in the software. First of all, it means you're underutilizing your database. And secondly, the people who develop the software implementations of the database functions are software developers. They tend not to be data people, so they do a good job but not a great job of doing that. And of course, then you ask the package to be customized, and the person who does that work is a consultant who is going to leave your organization after they're done, and you're left without a lot of the context that goes into that. So a very short piece on that. We'll remember to include that one slide in the rest of the presentation so everybody can get to that.
Okay.
The next question is, do you think data modeling will be used more in data virtualization than physical integration scenarios going forward?
You know, that's a great question. I wish I had a magic ball around that. I feel like, and maybe this is purely anecdotal, and I realize saying anecdotal data to a bunch of data nerds is probably not the best approach.
Oh, they love it.
I used to hear all the time about data virtualization, and I personally haven't come across it much recently in my professional career. So I'm not sure that I can really answer that one. I don't know that. I'm not sure.
I tend to say yes, though, because the one thing that is happening out there is that they've now taken the data storage technologies and put them also on Moore's Law, which means the price of these things is going to go in half every 2 years, and the capacity is going to double. The fact that we can do that means we can do more with virtualization, so I'm just going to see more growth in that area just based on that particular scenario.
All right, great. The next question is, most of the GIS data models are third NF.
Normal form?
Normal form.
We're making a data.
All right. But the same data is used for viewing in a large scale by a viewing application. That was, I guess, more a statement.
Follow-up maybe to the question. Right, so I assume that's causing performance issues. Is that what the same?
Possibly, that could have been.
Yeah, so I can see that, right? You're taking this massive amount of data that's highly normalized. You're needing to join it all together, which is very expensive, and it's probably got some performance issues. I hope that's what you were saying.
Again, the hardware vendors love it, right?
Right.
Okay, and the next question is, how do you deal with DBAs who only focus on performance, who are resistant to normalized design, use of FK constraints, foreign key, use of cascade deletes, etc., because they think it's going to degrade performance? Is performance the only concern?
I think out and out the answer to that is no. Performance is probably not the only concern, unless it's the only concern for that business case.
Which leads us to a webinar we did a couple months back on data strategy. So the key piece of that is, what is your data strategy going to involve? If your data strategy is focused on performance, as Stephen said, then absolutely everything else focuses on performance. And we know of a couple of organizations where that's really important, and we're really glad those organizations do that. It's probably not true for the majority of organizations.
Yeah, that's what I'm thinking too. I mean, it is difficult to answer based on a variety of factors, but I think in general, well, it's hard to even put a general response to it, but again, it's very specific, I think, to your individual issues and the business case for it. But I would argue that the DBA, his job is to try to argue for that, but there needs to be pushing from the other end, right, saying it's not always about performance. It's great that you're there and that you're an advocate for performance, because that is important, but at the cost of what, right? At the cost of having duplicate data or introducing poor data.
If they're making work for 10 of their buddies later on in the organization or a data cleanup organization, that could become highly problematic.
Buying yourself a couple of extra milliseconds on your writes or your reads downstream, if it's causing a lot of issues of integrating data to get some business insights, then it's definitely not worth it. On the other hand, if it's the difference between your customers using your application or not, then yeah, it probably is worth it.
All right, great. And the next question is, what is the difference between a data vault and data lake?
So a data vault, Stephen, is described to you as a class of modeling techniques that you can use to put in place to deal with rather complicated evolving systems under circumstances where a data warehouse might not be the best approach. We tend to use the phrase data lake to talk about just the overall environment in the organization. Right. The data lake is the way we like. It's typically a quality type of a process where people think of, I've got all this data in a data lake and I've got to go in and clean it up. Well, if we're going to clean up the water in the lake, we probably got to find the source of the pollution, because while it's a good idea to clean up the water in the lake, it's also a good idea to find the sources of the pollution and to eliminate them so we don't have to continue cleaning up the lake. Otherwise, it just becomes guaranteed work for somebody, and that's a wonderful thing, but...
Yeah, good response.
All right, next question is, what advice do you have for a recent college grad trying to break into the data modeling field, assuming they have a degree in the IT field with database management classes and data modeling classes?
Networking.
Yeah, it's all about networking, and at this point, I think you can really differentiate yourself, I think, by being able to speak kind of business's language. I think if you really focus on the IT side of things, that's great, and there's a lot of people with those skills. But if you can really try to bridge the gap between that IT knowledge and tying that back to a business case, I think that can be a big differentiator.
I would also say it's unfortunate that you're a recent college grad, because I would have taken your last course in college as an independent study and done a project for a company that you might want to go to work for in order to do that. Again, you may have some opportunities here. Again, there's a number of conferences. We have one of our favorites coming up is Enterprise Data World. It's going to be in Washington, D.C. If you're in the proximity of Washington, D.C. at the end of March, beginning of April, in addition to the cherry blossoms being wonderful, that time of year, we're going to have about 1,000 data modeling people in one place at one point in time. It's a great place to network and learn about some of these additional sessions that are there. If you have trouble getting introductions, let us know. We know a bunch of different people.
Okay, the next question is, imagine that there is a ERP implementation project. Therefore, there is no need for a physical model. Do we still need a modeling tool and effort if schemas and tables will be created by ERP tools themselves?
So this is clearly the cart before the horse in this case. I would hope that the organization had done it this way. They would have a logical model of the business requirements that they wanted the ERP to solve, and they would look at the various ERP options by comparing the logical models of the ERPs to the model that they have. I'll give you a very specific example on that we ran into in the U.S. military. One of the primary entities in an HR system is that an employee can be related to a position. And while that's an interesting, a person can be related to an employee. And most organizations implement that as a one-to-one relationship. In the military, many of the members and women of the armed forces have to have multiple jobs. So we have a requirement in the Defense Department that says that a person can be multiple employees. And looking for an ERP that has that multiple employees means we will have to do less of the workarounds that Stephen was describing before, and overall lower total cost of ownership to everybody. So I want that modeling to be done to help select the package. Once you have the package, you are likely to be asking the vendor for those particular models. So the vendor will give you the models in many cases, and you can use those models to help implement the integration as well as the data transformation from the old package to the new package as well. So the models, again, not modeling for modeling's sake, but what is the business problem we're trying to solve, and then can modeling be useful for it? And that's really what we're trying to do.
And I think also, just to follow up with that, we see so often people are jumping to tools to solve problems, and we think that really solving a tool should be further down the line. That may not necessarily be applicable in this particular case, but I think it bears repeating that we've come into organizations that have, we have all these different licenses for this tool and this tool, but we're still having these problems. And, you really have to address root causes before you determine a tool.
Technology is one of the three legs we'd like people to stand on. The other are people and process.
That's exactly right.
All right, great. The next question is, what's the consensus on reference tables? In that address table you showed earlier, you don't have state in a separate entity. But for example, in my experience as a product table would be split and have a separate entity of product category.
Yeah, I agree with that, and I think I mentioned that even kind of mid-presentation. I think someone else mentioned that. I agree. I think that table wasn't perfectly normalized. I think referential integrity is hugely important, and it's one of the massive benefits of going with a relational system. So, yeah, I agree with you absolutely. You can have people managing that data, ensuring that those reference tables are up to date and that they accurately reflect these business concepts. So, in general, I am all for complete normalization when it makes sense, and having absolutely everything in a managed reference table. All we're doing today is talking about how there's some cases where that's not necessarily the right answer.
Can we get that one?
Sure.
Okay. Go ahead.
Okay. Somebody was asking about the conversion between ER and triples.
So the key there, of course, is that if you're understanding the way open data and linked data is working in the real world, almost everything is being stored out there as an EAV triple, entity attribute relationship triple in there. And if you start to structure your data into that in general, you're able to use some of these techniques much more quickly. You don't have to restructure your data in order to get it into that environment. There's a couple of really, really good case studies that I could point you to. that will talk specifically about how much. But one of my favorites is a colleague of mine up in Fredericksburg who had looked at a $30 million data warehouse that's being built for the federal government. He was able to bring it in for $300,000. Those are the kind of numbers that people are going to pay attention to. Great stuff.
All right. The next question is, wouldn't it be great to have a wiki containing all of the different models and schemas?
If we could keep the vendors from suing us for putting their intellectual property out on the web, it'd be a great idea.
That's right.
So there are collections of these things, and DAMA does maintain some of these. You'll see a lot of them we collected into our DIMBOK, which is, again, a certification that everybody on staff has here in order to do that. We do have to be careful, though. You certainly would be able to do that internal to your organization a lot easier than we can do it externally, because some of these things are, in fact, proprietary to the organizations, and they don't want them to be shared. Now, we're happy to sign NDAs and work within those constructs, but that also means we don't just take whatever they have and put it out on the web. That's just rude behavior.
Right.
Okay, great. And the next question is, would you explain the differences between column family and tuple?
Tuple? Sure. Well, I guess they're not hugely similar, other than the fact that they're really going to have a key to their ordered data. The column family is really like a chart. If you can imagine it like a view that's operational. If you're thinking in third normal form, you're taking all these different tables and combining them into a view, right? That's really the main idea there, is that it's a massive amount of data, or not, but it can be a million different columns combined. With a tuple, I mean, really at its core, it is kind of a tuple already because it's got this key, and then as soon as you could think of these column families as values around that. So I guess the real question is performance-wise, and I tend to think of tuples as, well, I don't know. I mean,
bite-sized chunks.
Yeah, really bite-sized, more ordered data.
The key with column, though, is that they tend to be stored in memory. So the performance in columns tends to be faster, not necessarily because columns are a faster data structure, right, but because columnar databases tend to have a lot more RAM associated with them than the traditional databases.
Yeah, that's definitely a point we didn't touch on, but sure.
Okay. And somebody has been asking about having access to the slides after the session. Just want to let you guys know that they will be emailed out to you 2 business days after the webinar. So all the materials, you have the recording, any questions that were asked, those will be included as well. But it looks like that's all the questions we have for today. Thanks for all the wonderful questions, you guys. Thanks for an awesome presentation, Stephen and Peter. Next month we'll have a webinar on metadata strategies, so hopefully you'll be able to join us for that as well. As always, feel free to contact us if you have any questions. And thanks again to Dataversity and Shannon for hosting us. Thanks, everyone, and have a great day.
Thanks, Shannon.
Thank you.